Hello, everybody, and welcome to lesson 7.1 on page 415. And you see that it is on the Pythagorean theorem and it's converse. The converse is the same thing backwards. It holds true forward and backward. So let's start with the actual theorem. You already know it. This is kind of review for you, so I'm not going to make this a long video. In a right triangle, it has to be a right triangle. If it's not, then it doesn't work. So you want to make sure it's a right triangle. In a right triangle, the square of the legs, the sum of the square of the legs is equal to the square of the hypotenuse. The only thing that you have to remember is that the hypotenuse is the longest side. So that's the letter C. Okay, hypotenuse squared. The other two sides are called legs, and they're called A and B, and they're interchangeable. You can call one A and one B, it doesn't matter. It matters which side is C. So that is the important part. And our little formula here, A squared plus B squared is C squared. That's what I want you to look at. Remember, it has to be a right triangle. Always check, make sure it is. So let's go to the next page. We're going to look at triples. Triples, Pythagorean triples are three numbers that if you do A squared plus B squared is C squared, it'll balance your equation or it forms a right triangle. Yeah, so these are Pythagorean triples. 3 squared plus 4 squared is 5 squared. 5 squared plus 12 squared is indeed 13 squared, and so on and so forth. And I just want you to kind of recognize these. In other words, they're whole numbers that form a right triangle. Yeah, a Pythagorean triple has to be whole numbers that form a right triangle. Because sometimes, excuse me, our numbers are not whole numbers, as you'll see. All right, finding the length of the hypotenuse, which is our C, right? The legs of a right triangle, there it is, have the length 10 and 24. What is the length of the hypotenuse? So always start out by drawing it out. That helps you to see there is your right angle. The hypotenuse is always across from the right angle. So you can identify it easily that way. So I'll call that C. And then one leg is 10 and one is 24. Again, it doesn't matter which one. Those are interchangeable. So this is A, this is B, this is C squared. A squared plus B squared is C squared. So I'll plug it in, 10 squared plus 24. By the way, you do need a calculator. Definitely. Pause and grab one. 10 times 10 is 100. 24 times 24 is 576. 100 plus 576. Finish the question, don't add it yet. 676. And then in the end, you have to take the square root, always. 676, square root, it's 26. So that's a whole number, so those are Pythagorean. Okay, make sure you find your square root key. So C is 26. So do the length form a Pythagorean triple? Explain. Yes, they are whole numbers. Okay, so 10, 20, 10, 24, and 26 form a right triangle. Okay, now this part right here should look familiar to you, and I hope it is. Then let's go to page 417. which is, this is 18. I guess it's right here. So we're finding the length of a leg. So the legs are either A or B. Again, let's read the question and make a drawing if you don't have one. The hypotenuse of a right triangle has length 12. So I'll draw my triangle, identify the right angle, always identify the right angle, and this is my hypotenuse across. One leg has length 6. What is the length of the other leg? We'll call it X, okay, because it's unknown. So what I did was I drew a right triangle, identified the right angle, labeled the hypotenuse and the one leg. The other leg is unknown. This is called a diagram. 6 squared plus x squared is equal to 12 squared. 36 plus x squared is 144. Subtract 36. So you notice there's an extra step. You have to get x squared alone. You could also call this A or B, however you want, because it's a variable. I call it x. It really doesn't matter what you call it. If you like to call it A or B for the legs, that's fine. So we have x squared is 144 minus 36, 108. Don't forget you have to take the square root. So it says here, express your answer in simplest radical form. You could use your calculator and find the square root of 108, but you'll see that it has lots of decimals. It's called an irrational number, and those are not as accurate as simplifying. So I want to give you a little review how to simplify a radical or square root. So in our case, we have 108. And that's not a perfect square. In other words, you will not get a whole number answer. Try it out in your calculator. So in that case, we want to find a perfect square. What are the perfect squares? I start with 4 is a perfect square because it's 2 times 2. The next one is 9 because it's 3 times 3. 16 because it's 4 times 4. These are all perfect squares. When you take the square root, you'll get a whole number. So I'm kind of writing them down on the side to see if any of these go into 108. So I'm going to try 4. 108 divided by 4. I divide, yep, it's 27. So then we have the square root of 4 times the square root of 27. Because 4 times 27 is 108. Well, the square root of 4, you take the hat off, that's 2. And this is not a perfect square, but I already see that 9 goes into 27 3 times. So I'm taking the hat off the square root of 9, but that stays. So now I have to multiply. This is tricky. I have to multiply the parts I took out. The front here, 2 and 3 is 6 when I multiply it. So my final answer would be 6 times is about 6 times the square root of 3. No, actually, that's not an estimate. That's exact. Okay, these little simplifying radicals, I'm sure you have seen it in the past. You might have to refresh your memory, and I'm glad to show you a little IXL assignment on that to get more practice on how to do that, okay? Because in this chapter 7, you will have to do this a lot, simplifying your radicals. Remember, you want to have perfect squares. Square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Why? Because 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. What do you think the next one is? It's 25. The square root of 25 is, and I'm going to say etc. You can do these yourself all the way to 144, which is 12. So those are the ones that I always tell my students they should memorize. The perfect squares, the first 12, which is 100, goes up to 144. All right, so this is the exact answer that is preferable to the decimal that you get when you take the square root of 108. Okay, let's go to page 419. This is 419. Yep, there it is. This is the converse. In other words, backwards. Converse means say it backwards. So if the sum of the squares of the length of the two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So if this holds, if this is true, then you have a right triangle. If this works out, if one side, when you simplify it, is equal to the other side, then you have a right triangle. Okay, so let's try this one, identifying a right triangle. So you're given 3 lengths and you're supposed to tell if it's a right triangle. A triangle has side lengths 16, 48, and 50. So in this case, you're not finding a missing length, you're verifying whether or not these 3 numbers will form an actual right triangle. We don't know for sure, but we have to plug it into the formula a squared plus b squared is c squared and see if it's true. True means one side is equal to the other side. How do you know where each of the side lengths goes in the equation? You just have to watch for C. The longest side, C, now the other two, A and B, can be interchanged or interchangeable. So let's look at our numbers, 16, 48, and 50. So the longest side is C. These two are the legs. You can call one A and one B. Yeah, so this is the important part. Okay, so let's write it out. 16 squared plus 48 squared. And we're checking if that is equal to 50 squared. And I'm going to put a question mark here because we're not sure if it is 50 squared, right? So let's use our calculator. 16 squared means 16 times 16, 256, plus 48 times 48, or you can say 48 power of 2 is 2,304. 50 times 50 is 2,500. Short version is 5 times 5, add 2 zeros. Now we have to add these, 256 plus 2,304. And now that doesn't work out. See how that side is bigger? That's 2,560 does not equal. See how they're, notice I keep the right side. I consistently use my 50 squared. I'm not adding this up. I'm trying to compare which side is, if it's equal or not. No, these numbers do not form a right triangle. Okay, so we want both sides equal. So that's pretty much it for this lesson. So the next page, I think I'm skipping the next page, and let's go straight to our homework. This is page 423, theorem. So you have to do number 11. Your answer should be in simplest radical form. Look at my example. See if you can figure it out. Not only do you have to find the answer, you have to simplify your radical. Remember, you're looking for two that multiply to that. One you can take out, the other one you leave in. Number 12, actually you're only going to do this page. 14, 15, and then an error, there's a mistake, find it, explain it. And this one is your only one that maybe a little, I don't know if you've ever seen an embroidery ring where you embroider in the middle, you put the fabric in a clamp, and then there's a good way to just keep stitching because it's all tight, right? I'm not sure if you've seen it, I have. So let's read that. Think about a plan. You want to embroider a square design. There it is. This is your square design. You have an embroidery hoop with a 6-inch diameter. The diameter means it goes from here to here all the way through. Notice now you have a right triangle here. So the question will probably ask you about this right triangle. Notice that, right? Here's your right angle, okay? Find the largest value of x, which is the side length. Notice they're the same because it's a square, right? In a square, each side length is the same, so we call them x because they're the same number. We have to find the number, that's the thing. Find the largest value of x so that the entire square will fit into the hoop. It does if you go from here to here. Round to the nearest tenth. So no simplifying radicals, you're actually going to take the square root with your calculator. Now you have to answer these questions. What does the diameter of the circle represent in the square? That's your C. It's the hypotenuse of your right triangle, right? What do you know about the sides of the square? Well, there are two, I'm going to help you out a little. Start you off, x squared plus x squared, the legs is equal to c, which is 6, right? So your job is to find x. What number squared? You need to probably simplify the x squared plus, so think of it as 1x squared plus 1x squared. How many x squareds do you have? And then isolate your x squared and take the square root at the end. Okay, so that's my clue to find the side length. All right, like always, when we get to class, I will help you if you have questions. See you later.